Questions 21 through 25 on the 2010 Grade 8 Gauss Math Contest. In the diagram, AB is parallel to DC and ACE is a straight line. The value of x is. Here's this diagram blown up a little bit. Now, the angles about a line all add up to 180. So if this is 105, this angle in here has to be 75. Okay, now this angle in here, I'm not sure, so I'll just call it y. But one thing is for sure is that x plus 115 plus y, those angles that make up that triangle, have to add up to 180. So I can isolate for y. It will be 65 minus x. So I can put that in here, 65 minus x. Now at this point, we have to take into consideration something they told us in the question, that AB is parallel to DC. This line right here is parallel to DC. So I'm going to extend DC like that. Well, I think that's far enough. And when you do that, something cool happens, that if you remember, if you have parallel lines like that, this angle will be the same as that angle. So if that's 75, this angle from there to there is also 75. So now all the angles about that line must total 180. And therefore 75 plus this 75, this one and this one, plus this 65 minus x, all equal 180. So doing the math here, we get 180 is equal to 215 minus x, and therefore x is equal to 35. So number 21, the answer is A. The values of R, S, T, U are 2, 3, 4, and 5, but not necessarily in that order. What is the largest possible value of R times S plus U times R plus T times R? So we have R times S plus U times R plus T times R. Well, factor out an R, since that's common to everything, and you're left with this S plus U plus T. And this is what we have to maximize using these four numbers. Well, I'll let my R equal 5, and then obviously the remaining numbers go in here. So in any particular order, 3 and 4 like that. And when you do this, you get 5 times 9, and that's 45. And if you rearrange this to give other values for R, you'll notice that the sum will only get smaller. So the largest possible value is 45, and therefore number 22, the answer is B. To shovel all of the snow on the driveway of Kevin, he needs 12 hours. Individually, Dave needs 8 hours to shovel all of Kevin's snow. John needs 6 hours to shovel all of Kevin's snow. And Allison needs 4 hours to shovel all of Kevin's snow. If Kevin, Dave, and John and Allison all work together, how many minutes do they need to shovel all of Kevin's snow? As always, I always like to use a number. So I use a number that somewhat evenly divides 12, 8, 6, and 4. It probably divides all of them. I chose 24. And it doesn't really matter. But 24 meters cubed, let's say, that's the amount of snow on Kevin's, I'm assuming, driveway and sidewalk. That's usually where people shovel their snow in Canada. So now let's talk about Kevin, Dave, John, and Allison. So Kevin, to shovel that 24 meters cubed, it takes him 12 hours. So that means he shovels 2 meters cubed per hour. Correct? Dave, to shovel that 24, he takes 8 hours. So that means he takes 3. That's his rate of shoveling. John is 24 divided by 6, which is 4 meters cubed per hour. And then finally, Allison is 24 divided by 4, which is 6 meters cubed per hour. Now, if they all work together, then you combine all of this. So that means 2 plus 3 plus 4 plus 6, which is 15 meters cubed per hour, is how much snow they can shovel, remove from any driveway or sidewalk. Now we have to remove this much, so it would be 24 meters cubed divided by 15 meters cubed per hour, and that is 24 over 15 hours. In decimals, that is 1.6. 1.6 hours is the answer to this question. Now, they have given it in minutes. Okay, no problem. Multiply 1.6 times 60 to get minutes, and that would be 96 minutes. So number 23, the answer is D. Two circles each have a radius of 10. They overlap so that each contains exactly 25% of the other's circumference, as shown. The area of the shaded region is closest to. I would like to make this a bit bigger, since this diagram is at the heart of the question, and I think that's sufficient. Okay, so the first thing I want to draw is the center of this circle, and I'll draw lines to that point and lines to that point. Now, this piece of information is important. They overlap so that they each contain 25% of the other circumference. So that means this segment represents 25% of the total circumference all the way around, like that. What that basically means, the interpretation of that, is that this angle is 25% of the total angle. Now the total angle all the way around is what? 360, right? So this angle right here has to be 25% of that. And if you do that math, you get 90 degrees. And that's why I put a little right angle there. So now we are in a better position to calculate that shaded region. First thing I'm going to do is drop a line to cut that shaded region in half. And when I do, I will label one of that shaded region A. And that's A and that's A. So I'll just leave that labeled as A, and therefore the shaded region is the equivalent to finding 2A. First we'll calculate A, and then you can just multiply it by 2 later. So how do we calculate A? A is calculated as follows. First and foremost, you take this area, which is sort of that pi segment, right? And that pi segment is basically the area of the circle divided by 4. It's a quarter of the circle. That's what that 90 degrees helps us to determine. Once you find that pi segment, from it, subtract this triangle. If you do that, you'll get A. Now, how do you figure out the area of that triangle? Well, it's 1/2 base times height, like that. And I think most of these things we know. So pi, obviously we know r is 10. And then 1/2 base times height. Well, the base and the height, if I call this, say, the base and the height, both of those are the radius. So one is 10 and the other one's 10. And that's it. So this is going to be 25 pi minus 50. And that's A. Now, of course, I want to figure out 2A because the area of the shaded region is 2A. So that's going to be 2 times that, which is obviously 50 pi minus 100. And that is equal to approximately 57. And of the answer choices, the closest is choice A. In a sequence of 10 terms, the first term is 1, the second term is x, and each term after the second is the sum of the previous 2 terms. For example, if x is 11, the sequence would be 1, 11, 12, 23, 35, 58, 93, 151, 244, 395. For some values of x, the number 463 appears in the sequence. If x is a positive integer, what is the sum of all the values of x for which 463 appears in the sequence? we have the first term, second term, third term, fourth term, and so on, right? Good news is we only have 10 terms. And much better than having 100 terms or infinite terms. Now they tell us the first one, they give us that is equal to 1. Okay? The second term they tell us is x. And then every term after that is the sum of the previous two. So the third term would be obviously 1 plus x. The fourth term would be this plus this, which would be 1 plus 2x. The fifth term is this plus that, which is 2 plus 3x. And so on, right? So I'll just fill them all in. We've got here 3 plus 5x. And then we have 5 plus 8x. And then 8 plus 13x. 13 plus 21x. And the last one would be 21 plus 34x. So as long as you don't mess up on the math there, this should be fine. Now, we want 463 to appear. How do we do that? Well, for the first one, obviously, it's set as 1, so that can never be 463. But if this one was set as 463, then that means that 463 has appeared somewhere. Okay, so that's one possible value for x. Okay, we'll circle it and keep it. What about if my 463 in a different sequence, not this one of course, but in some different sequence, if this value was 463? If that is the case, what is my x value going to be? Well, x would be 462. Okay, I'll keep that as a possible value of x. In another sequence, if this was set to 463, then that would mean 1 plus 2x is 463. And then solving, you get 2x is equal to 462. And therefore x is equal to 231. Okay, great. I've got another value. Let's keep going here. In another sequence, if that fifth term, 2 plus 3x is 463, then let's see what we get for x. Now that means 3x is equal to 461. And therefore x would be about 153.6. Now this we don't include. Why? Because they only want positive integers for values of x. So if it's not, that's not something that I can include in my sum. Okay, no problem. Let's keep going here. In the same story, basically, we're going to set all of these to equal 463 and then solve for x. And if it's an integer, we keep it as a possible value of x. So doing this one, 3 plus 5x is 463. 5x is equal to 460. And therefore x is equal to 92. Okay, that's an integer, so I keep that. All right, keep going here. This now is going to be equal to 463. And if you do the math, you get 8x is equal to 458. And therefore, x would be equal to approximately 57.2, I think. 57.25. So we don't include that because that's not an integer. All right, we have a couple more, or 3 more actually. 8x plus 13 is equal to 463. If we do that, we get 13x is equal to 455, and therefore x is equal to 35. Okay, great. We keep that one. And then we got a couple more. So now that, if I set that equal to 463, I get 21x is equal to 450, and therefore x would be equal to 21.4, not an integer. And then finally this guy, if I set that equal to 463. I've done it so many times, still can't remember. And that would be 463 minus 21, which is 442. And therefore x here is equal to 13. Okay, got another integer. So now my task is to add up the values of x that I got. So this one, this one, this one, this one, this one, and that one. And when you do, you get a grand total of 1296. And then for number 25, the answer is B.